Hello guys, in this video I'm going to show you how to rationalize denominators. It is actually improper to write, not that the value will be different, but it's important to have radicals and denominators. Like, for example, if you have 1 over square root of 2, it's important to write it this way because you have a radical in the denominator. So if you have an expression like this, it will be required, your instructor may require that you rationalize the denominator here, okay? And by doing that, by rationalizing the denominator, it means you're trying to remove the radical in the denominator, trying to make sure that you do not have a radical in the denominator. This symbol, trying to eliminate it in the denominator, it should not be there, okay? For you to have a proper fraction. Okay, so for it to for you to make sure it's not an improper form, okay? So just make sure you get rid of the radical and the denominator. Okay, I'll take this example to start, okay? So we can start with this. So if I want to eliminate square root of 2 in the denominator here, and I don't want to change the value of anything here, well, one thing I can do, I can multiply by the number 1, because only when you multiply by the number 1 that you won't change anything, okay? Now, if I multiply by number 1, I'll still get the radical in the denominator, right? So in order for me not to get the radical in the denominator here, this radicand must have been a perfect, in this case, a perfect square, because it's a square root, right? If it was a number like 9, then square root of 9 would be 3, then I wouldn't have the radical. If it was 4, square root of 4 would have been 2, and I would be gone, the radical would be gone, right? So it turns out that I just need to make it look like a perfect square. I just need to change 2 to make sure it's a perfect square, right? And once I have a perfect square, then I can remove the radical because it's the square root of that perfect square, right? So instead of having 1, I may have a number divided by itself, right? Like x divided by x. In this case, this would be 1 still. So it would make sense. It wouldn't change the value. Well, okay, so if it's the same thing, it wouldn't change the value. What if I just multiply and divide by square root of 2? This will help me. Now, it will not only make this a perfect square, but it will also keep the value of the entire expression, because I just multiplied and divided by the same thing, the same number, square root of 2, right? Which is 1. So it's as if I'm multiplying by 1, okay? All right, so the key here is to just make sure you get rid of the denominator and the radical in the denominator. And to do that, make sure you multiply and divide by the same thing. So in this case here, once I do that, I'll end up with 1. So on the top, I have 1 times square root of 2, which is square root of 2. On the bottom, square root of 2 times square root of 2, which is square root of 4. And guess what? This is square root of 2 over, because that's 1 times square root of 2. So it's square root of 2 over square root of 4, which is 2, okay? And once you reach this point, there's no radical in the denominator, you know it's done. You just rationalize the denominator. So this is good. Same value as what you had previously, which was the 1 over square root of 2, okay? So this is how you rationalize denominators. I'm going to take 1 or 2 more examples just to make sure you get this. All right. So let's do another one. We have now 15. Let's say 15 over, so 15 over cube root of 25s. 25s, okay? So cube root of 25s. Okay, 15 over the cube root of 25s. So now I need to get rid of the cube root. Therefore, I need a perfect cube right here. I need this to be a perfect cube, right? 25 is a perfect square. So if I break 25 down, that will be 5 times 5. But I need to have a perfect cube. So what if I multiply by another 5? Well, that will make it 125, which is a perfect cube. How about the s? I had s, then s again, it's s to the first. If I had s cubed, it would have been a perfect cube. So what's missing is just the 5s to the second, okay? Let me show you what I mean. Let me write it down so you could actually see what I'm saying here. Okay. Right here you have to make this a perfect cube. So if I multiply the 25 by 5, that would make it 3 5s because it's 5 times 5 times 5, which would make it a perfect cube. If I multiply the s by 2 other s's, meaning s to the second, then it will be x cubed, which would be a perfect cube. Then I can eliminate the cube root, right? Once you realize you take care of the bottom, you can then multiply the top by the same thing. Cube root of 5s squared, by the way. Okay? And now let's do the math. Simplify this, right? Okay, so now we have 15 cube root of 5s squared, okay, over, now this is the cube root of 125 because that's 25 times 5, 125 s cubed, okay? Let me make sure my 5 does not look just like my s, right? I think that's the problem I have now. 125, right? So 1, 2, 5, and s cubed, okay? Now, as you can see here, the bottom part is a perfect cube now. So you can just do cube root of 125 s cubed. That's just 5s, right? 5s. And the top part would be 15 cube root of 5s squared, okay? And then you can actually simplify here, right? You can simplify because you have 15 here and 5 here, so we can simplify by 5. 5 goes into 15 3 times, okay? Therefore, the answer, final answer, by the way, would be 3 cube root of 5s, 3 cube root of 5s over s squared, by the way, I forgot to put the 2, 5s squared over s, okay? So 3 cube root of 5s squared over s, okay? This, now, when looking at it, you don't see a radical in the denominator, so you know you're done. This is rationalized, okay? You don't have a radical in the denominator, okay? Now, I'll try another one. These are the ones with 1 radical. I'm going to try one with 2 radicals, and that will be it. Because you just need to know now the one with 2 radicals. Okay, let's say we started with this one here. 2, negative 2 over 2 plus square root of 6. So negative 2 over 2 plus square root of 6. Okay, let's say you had this one. Now, one thing to know, if you have two terms here, or it could be 2 radicals or 2 terms, then it's much harder for you to do. So now you need to get rid of this radical here. You cannot just multiply it by something to make it squared because, you know, this is a unit by itself, okay? So the best thing to do here is to try to remember what we have when we multiply a plus b by a minus b. When we do that, the factor we'll end up with would be, the binomial will be negative a squared minus b squared, right? And once you square this part here, which would be this part here on the right, it will get rid of the radical. Then you would be fine. You won't have a radical in the denominator, right? So that's why the best thing to do here is to multiply by what's missing, the factor that's missing, which is this. In some other cases, you would have this factor. What would be missing would be this one, the a plus b. So as in this case, I'm going to do what I have for this case here. Let me rewrite the problem, and I'm going to keep what I have up there just to remind you of the formula, right? So you go square root of 6. Now, I'm going to multiply, as I said, by 2 minus square root of 6. And on top here, I'll do 2 minus square root of 6, the same way. Then this thing here will be on the bottom. Now, as you can see, as what I said here, according to the binomial you have here, I can write, I know it's like a plus b, a minus b. So I can write this as the square root of a, so 2 squared, minus the square root of the second one here. So square root of 6 squared. And on the top part, it would just be the negative 2 times 2 minus square root of 6. Okay? Should make sense to everybody here. Okay? Now, from here, guys, let's keep moving. Okay? What I have here, I can distribute on top here, or I can leave it the way it is for now. Don't want to change anything for now. I can just put negative 2, then 2 minus square root of 6, okay? And on the bottom, 2 squared is 4, minus square root of 6 squared is positive 6, which the negative sign outside will keep as negative 6, okay? The radical is gone because you square it, all right? So now it's negative 2 minus square root of 6 over 4 minus 6 is negative 2. 4 minus 6 is negative 2. So now, as you can see, the negative 2 you have up there is also down there. So 2 of the same factors, you can actually cancel it out. And final answer will be just 2 minus square root of 6, okay? And as you can see, there's no denominator now, so you don't have a radical in the denominator, and this is rationalized, okay? So this is what you do to rationalize denominators. By the way, this part I just multiplied this by is called the conjugate of what you had here, the conjugate, okay? So it's called the conjugate. So for example, if you had if to start you had a minus b, the conjugate of this would be a plus b. If it's a plus b, the conjugate would be a minus b. So you multiply by the conjugate in this case, all right? So that's what I had for you guys. This is how you rationalize denominators. Okay, thank you.